This is Physics Ramakrishna sir, IIT JEE faculty. In the last session, I discussed about the concepts of relative velocity of approach and then separation. Today, I want to give the one basic model and very different model I want to give on basis of relative velocity concept. Here, one application problem I am discussing. Here, a body is thrown with some velocity v. It is reaches to the fixed point, so that the velocity as well as the perpendicular distance, so it is a distance, fixed distance remains constant. It is not a perpendicular distance, it is a fixed distance. There I am taking the fixed distance value is r is equal to 10 meters. So this is follows in such a way that this angle is remains constant as this velocity, as this particle is approaches to the fixed point. For velocity and then this distance to be makes the same angle at every instant of time. At any instant of time, this fixed distance as well as this velocity are making the same angle. That is the condition for the problems. Here, with respect to the fixed point, this velocity as well as this position vector are making the same angle. Now here, after what time this particle is going to be reaches to this fixed point. Now here, let the direction of this would be, this is the direction. After certain instant, this particle will be here. After certain instant, now the distance is fixed, and now this first makes an angle of 37 again. Fixed distance is going to be changes. Now here this velocity as well as distance vector should be makes an angle of 37 again. Here this is the initial velocity vector directions. And again what happens now here, the direction of the particle is going to be changes. Again this fixed distance is makes an angle 37. Like this 37. Now finally the particle is coming to in this way. Now the distance is remains fixed, and now the path would be like this, so that it reaches to the approach to the fixed point. As it is approaches to the fixed point, the distance is decreasing with respect to the time. So this is the velocity of approach, we can say. This is minus dr by dt into relative velocity concept. This relative velocity cos theta, Vr cos theta we can write. This is only one velocity is given there. There is V cos theta given. V cos 37. There V will be provided to you. It may be the constant velocity or variable velocity. So I am taking the case one, that V I am taking the constant velocity 10 meters per second. So I am taking the constant velocity. Now here dr we can write as, this is a fixed distance, this is changes from 10 to 0, this would be 10 to 0, that must be equal to this V 10 into cos 37 4 by 5 cos 37 value. Now here this is 8, this is into dt, integrate from 0 to t time interval. Now this dr can be changes, so this is 10 is equal to this 8 into t we can write there, t can be taken as, this is 5 by 4 seconds. After 5 by 4 seconds the particle reaches to the fixed distance, fixed point. After what time the particle is going to be reaches to the fixed point. The time is what? 5 by 4. So suppose if I take the variable velocity, suppose the velocity is as a time function, if I take case 2, If I consider the velocity is equal to t, I am considering this is a time function velocity. So in this case, in the situations, we can write the time taken. How to find the time taken for this? This minus dr by dt can be taken as v cos 37. We can write there v I am taking as 2t, four by 5 to dr dt. This is changes from 10 to 0. This fixed distance is 10. I already provided the fixed distance would be 10. Now here this 10 would be equal to, this is 8 by 5 into t dt. We can write here, we can write 0 to t time interval. This would be 10 is equal to, so 8 by 5 into, this would be t square by 2 we can write. So from this we can write this by integrating this one, this is 20 into 5 by 8, this is t square. This t value becomes 25 by 2, this is root over, this t can be taken as 5 by root 2 seconds. So here like this we can calculate the time taken for approaching of the particle. As it was the condition I already provided to you that the velocity vector and then the fixed distance is making the same angle, similar angle here. They were making the same angle. Then after what time this particle is going to be reaches to this fixed point, I am calculating the time interval. There I am taking the velocities are one constant velocity in case 1 and variable velocity in case 2 I took here. Like this we can calculate the time taken for approach when a particle is projected or body is projected. So thank you very much.